Hi everyone. In this series, we will be looking at good actual CAT questions along with smart solutions. Now make sure that you pause the video and try out the question yourself before you take a look at the solution. And at the end of the video, we'll also provide a replica question that you can use for extra practice. Let's get started. Now in this question, we have that a glass contains 500 cc of milk and a cup contains 500 cc of water. From the glass, 150 cc of milk is transferred to the cup and mixed thoroughly. Next, 150 cc of this mixture is transferred from the cup to the glass. Now the amount of water in the glass and amount of milk in the cup are in the ratio, and that is what we have to find. Now the question doesn't seem to be very complicated, but the thing is, if we start solving it using the traditional method, it will become time-consuming, calculative, and we will be at a disadvantage in the CAT. So first I'll show you the problem with the traditional method, and then we will see the best way of solving this question. So what we have here is a glass first of all. Let's represent it with a G. And glass contains milk, okay, which is 500 cc of milk. And that is all. So the water content here is 0. And then we also have a cup, which is C. And this has 0 milk, but this has 500 cc of water. So this is what people would start with. And then from the glass, 150 cc of milk is transferred to the cup. That part is simple. So milk 150 cc is being transferred. 500 minus 150, now 350 cc of milk will be remaining. Water, nothing is happening, it will be 0. And then 150 cc of milk will be added here from the glass to the cup. So this will become 150. Water is not changing, this will remain the same, 500. Now this part is the simple part, but the next step is the difficult one, because then 150 cc of the mixture in the cup is being transferred to the glass. Now, in the cup right now, we have milk and water 150, 500. So if you look at that ratio, 150 is to 500. If we divide by 50, we will get 3 is to 10. So milk and water are in the ratio 3 is to 10. So when we are transferring, whatever total quantity we are transferring, that will also be in the ratio 3 is to 10. Now the thing here is that 3 is to 10, when we add, we will get total 13 parts. 3 plus 10, 13 parts. And neither of these two values is divisible by 13. So that will be a problem with calculation. Okay, for example, if we think about milk, milk is represented by 3 parts. So milk will be 3 upon 13. And total that we are transferring is 150 cc of the mixture. So 3 upon 13 into that total 150 will be milk. Now see, this is a fractional value. If you use the calculator, you'll get a decimal. But that is not convenient for calculation, because then when we transfer it, we'll get a decimal value overall. And then we have to calculate water also. And then, of course, the calculation process will take a lot of time, even with the help of the virtual calculator in the CAT. So I don't even want to continue with this because it's a waste of time. It would take too much time to solve this question. So when you see that the calculation is very, very tedious, okay, very inconvenient, then you have to think there might be a better method. And this is where experience helps, because if you have practiced enough, this is a classic kind of question you might have come across in your preparation. So let's now come to the better method. So in the better method, we have to think that ultimately we have to focus on the final amount of water in the glass and the final amount of milk in the cup right at the end, after everything has happened. So let us just try to come to that final situation directly. Let's see whether that is possible, okay, so that we can avoid all the tedious calculations. So we have again a glass with milk and water, and we have a cup with milk and water. We don't care about what is there at the beginning, what is happening in the middle. We are just coming directly to the end. Now at the end, we don't know the actual quantity. We are avoiding that calculation. So if we take the final amount of milk in the glass as X, any variable, for example, X. Now here you have to think that the total amount of milk has to be 500. Because ultimately we are just taking 150 cc from glass to cup and 150 cc from cup to glass. So we are just transferring back and forth. Okay, so the 500 cc of milk Some of it is being transferred to the cup, some of it transferred back to the glass, but overall, glass and cup combined, in total, it is remaining 500. So out of that total 500 of milk, if X is here in the glass, then the remaining 500 minus X will be there in the cup. Okay, so that total we still have 500 of milk, which is what we need. And then we have to think that in the glass, at the beginning we had 500, and then 150 was transferred to the cup. Then 150 of mixture was transferred back to the glass. So in the glass, we will still have total 500 quantity at the end. Okay, because whatever is being transferred to the cup, it is being transferred back. So the total quantity at the end will be the same as the initial quantity. So initially, if we had 500 in the glass, finally also we will have 500 in the glass. So out of that total 500, we have X. So the remaining part in the glass will be 500 minus X, which will be water. And we can see the same thing for the cup. Initially, we had 500. At the end also, we will have 500. So out of the total 500, if we have 500 minus X here, we will have X here. So that the total is 500. And actually, this X we don't even need to find. Because if you look at what the question is asking, it's asking for the ratio of amount of water in the glass, which is this 500 minus X, and the amount of milk in the cup, which is also this 500 minus X. So of course, this ratio will be nothing but 1:1 because these are the same value. And this is how we can easily get the correct answer. So once you understand this logic and once you have experience with this kind of question, you can see that you can solve this question in less than 1 minute. Whereas other people using the traditional method would take easily 3 minutes. Now let me show you a replica question. This is a question that you can practice. Try it out using the same method and make sure that you put the answer in the comment section.